Section 8.6 is all about using the quadratic formula. The quadratic formula can be used for any of our quadratic functions where we have ax squared plus bx plus c set equal to 0. So remember, you have to get it into what we call this standard form, which is this a times x squared plus b times x plus this value c equals 0. It has to be set equal to 0. Now, whatever the value of a, b, and c is, those can change, and those can be positive or negative. But if you can get it into this form where it's equal to 0, then the two spots that this will be true, like the two solutions for this, would be if you have x equals negative b, so whatever this b value is goes right here, negative b plus or minus the square root of that same value b squared, so take that value multiplied by itself, minus the amount 4 times a times c, so 4 times this number times this number. All of that is under the square root, either added or subtracted from negative b. All of that is divided by 2 times a. So whatever this value is, multiply it by 2, and that's the denominator of this expression. So let's see that in action. First, for these examples, we need to write each equation in standard form, then identify a, b, and c. So in this form, 8n squared minus 10 equals negative 7n. We don't have it set equal to 0, so we want to change it so that we have it set equal to 0. How would we do that? Well, we can add 7n to both sides. When we do this, that'll cross it out on this side and just leave 0. And it would look something like this. 8n squared plus 7n minus 10. Now again, part of the reason we write it in this way, remember back to our polynomials unit, we always put terms with the highest degree first. N squared, so n to the second power. This 2 is higher than this 1. This is n to the first power, so this degree comes first. 8n squared plus 7n minus 10 equals 0. Now that we have it in this form, our a value is 8, this piece here. Our b value is 7, positive 7, this piece here. And our c value is negative 10, this right here. Notice c is not 10, it's negative 10 because we have minus 10. Let's look at this one. Again, to get it set equal to 0, we need to add 12a to both sides. Add 12a over here. We also need to add 3a squared. There's already 2a squared here, so it'll just add on to that already a squared term. 2a squared and 3a squared makes 5a squared. There were no a terms over here, so let's just add that 12. Oops, this should be an a, not an n. And we still have just that plus 8 at the end. Now, like before, this will cancel out, this will cancel out, leaving just 0. Now that we have it set like this, our a value is this first one, 5. Our b value is this first one, positive 12. And our c value is this third one, positive 8. A, b, and c, after, you can only find them after you've set it into standard form. Example 2, we're going to solve these problems using the quadratic formula. So the first thing you always want to check and make sure is that they are in standard form. X squared plus 4x minus 25 equals 0. That is in standard form. It is set equal to 0. So we'd say our a value is 1, our b value is 4, and our c value is negative 25. So all we have to do is use these values and plug them into that quadratic formula. X equals negative b. B is 4, so it's negative 4. Plus or minus the square root of all of this, b squared, again, b is 4, so we just plug in 4, minus 4 times a times c. A is 1, c is negative 25, so 4 times 1 times negative 25. This whole thing is divided by 2 times a, so it's 2 times 1. All we're doing is just plugging these values in to the quadratic formula. We're going to simplify it just a little bit. Negative 4 is still negative 4, plus or minus. Instead of 4 squared, well, that's 16. And 4 times 1 times negative 25. 4 times 1 is 4. 4 times negative 25 is negative 100. So 16 minus negative 100. And 2 times 1 is just 2, so it's all over 2. Now, you might have noticed 16 minus negative 100 is the same as just saying plus 100. So we would simplify that down then. Negative 4 plus or minus the square root of 116. 16 plus 100 is 116, all divided by 2. Now, at this point, because 116 is not a perfect square, we cannot get that square root, so we could just say this is our answer. But if you like to be a little more exact, you'd plug this into your calculator and find the decimal roots. You'd get 3.38 or negative 7.38. Again, one of these was found by doing negative 4 plus this amount and then dividing by 2. That would be this answer. One of them we did negative 4 minus this amount and then took that answer divided by 2. And that's how we got this negative 7.38. So either one of these answers is acceptable. Example 3, solve using the quadratic formula. And again, always remember we need to get it into standard form first. X squared plus 2x equals 8. That is not standard form, so we need to subtract 8 from both sides to get it there. Those would cancel out, and we'd be left with x squared plus 2x minus 8 equals 0. In that case, a is still 1, b would be 2, and c would be negative 8. Take those values and we plug them into our quadratic formula. X equals negative b, so negative 2, plus or minus b squared, so 2 squared, minus 4 times a times c, so 4 times 1 times negative 8. All of that is divided by 2 times a, or 2 times 1. Simplify that down a little bit. It's still negative 2 out here, plus or minus. 2 squared is 4. 4 times 1 is 4, times negative 8 is negative 32. So 4 minus negative 32. 2 times 1 is just 2. Like last time, you might have noticed 4 minus a negative 32 is the same as saying plus 32. So when we try to simplify that piece, negative 2 is still here, plus or minus the square root of 36. 4 plus 32 is 36, all divided by 2. Now we know the square root of 36, so we can't leave it like this. We would say it's negative 2 plus or minus 6 divided by 2. Now if we did negative 2 plus 6, that would give us 4 over 2. If we did negative 2 minus 6, that would be negative 8 over 2. So these are going to be our two answers, and we can simplify them down. 4 over 2 is just 2. Negative 8 over 2 is negative 4. So these would be our two possible solutions. Last example, example 4. We're going to use the quadratic formula yet again. We need to get it into standard form. This one gave it to us in a factored form. So how do we kind of solve this out or undo this? We'd have to use our distributive property, 3x times x, and 3x times minus 4. That's going to leave us with 3x squared minus 12x. All of that equals 2. Now, after our distributive formula, it is still not in standard form. So, what do we need to do? We're going to have to subtract 2 from both sides of our equation. These will cancel out, and we will get 3x squared minus 12x minus 2 equals 0. Now, we have it in standard form, and we can say that a equals 3, this piece right here, b equals negative 12, this piece right here, and c equals negative 2, this piece right here. We're going to use those and plug it right back into our quadratic formula. X equals negative b, so negative 12, plus or minus the square root of negative 12 squared. That's negative, or b squared. minus 4 times a times c. So 4 times 3 times negative 2. All of that divided by 2 times a, so 2 times 3. Simplifying that down, negative 12 is just positive 12. So we'd have a positive 12 right here, plus or minus negative 12 squared is positive 144, sorry. And 4 times 3 times negative 2 is negative 24. So it's the square root of 144 minus negative 24. All over 2 times 3 is just 6. Now again, like before, we have minus a negative, so we can just call it adding. So we can simplify this down to 12 plus or minus the square root of 168 all over 6. Now again, 168 is not a perfect square, so we can just leave it like that. Or if you like to find the exact decimal answers, if you did 12 plus square root of 168 and then divided it by 6, you'd get 4.16. If you did 12 minus the square root of 168 and then divided that answer by 6, you'd get negative 0.16. Again, either of these answers are acceptable, either this way or this way. And these are the two solutions of x that would make this equation true. And that would be solving with the quadratic formula.